Greetings and salutations. Thanks for hanging out with me for a while. In this video, we're going to look at some of my favorite bash commands. A few of you out there have been saying, hey, can you do some more advanced terminal stuff? We like that. So that's what we're going to do. Even if you're just starting out, hey, hang out. You might learn something. So bash, it is the default shell for most Linux distributions. When you open up a terminal, you are working in bash. It is a command line interpreter. Not only can it run other programs, but bash has built-in commands, and it also has its own programming language. And we're going to touch on a little bit of all of that in this video. A few things I got to tell you straight up front. First of all, not every one of these commands is a practical command that you can use every day. Some of them are more suited to working in scripts, and some of them I just like because they're super cool and they really illustrate something about how bash works. So that's why I have chosen them for our video today. A few of these commands are powerful enough that if you use them in the wrong way with the wrong arguments, you may cause severe damage to your system. Now, which ones those are, I will tell you as we roll along, but I do want to say proceed at your own risk. I will not be held responsible if you bork something up. Be careful out there. Remember, bash assumes that you know what you're doing, so make sure you do before you do it. And finally, these notes that you're looking at cannot be posted in the description to this video because YouTube bans certain characters, namely brackets, and some of these command strings of code have brackets in them, and so therefore I can't post it. But what I'm going to do is I'm going to put this on my webpage underneath the video itself in the news section where I always announce new videos, and I'll put the link in the description for this video. If you're like the second or third person to watch it, it probably won't be there yet. Come back later, it will be. It's going to take me a little while to get that all straightened out. You know how that is, because I have to publish the video first, then I got to go put the video on the web page, and it goes that way. So let's jump in. I think this is going to be a lot of fun, and we're just going to hang out and talk about what these commands do and how they work and all that kind of stuff. So grab a beverage, pause. I'll wait a second here, get yourself ready, and let's go. Command number one is not one that I'm going to show you working because there's not a whole lot to see. I did try it in a virtual machine, but it didn't show much on the screen. So I'm just going to tell you about it. And it's probably the most boring one, and so we put it up front so we can get it out of the way. What we're talking about here is creating a flag file to get the system to do something. One of the concepts in working with Unix and Linux is that you can use flag files to signal programs. Sometimes they're used in scripts to leave a message behind for another program. And a flag file can be one of two things. It can either be a file that actually has some sort of data in it, like maybe a timestamp or a date or something like that, or it can just be an empty file. And in this case, that's what we're creating with this command right here, sudo touch. The name of the file that we're creating is forcefsck, and we're putting it in the root directory. And what that does, the next time you actually boot the system, it tells the kernel at boot time, hey, before you mount the file systems that are in the fs tab file, make sure that you check them thoroughly with fsck. Most Linux systems, when they boot these days, already do a fsck, especially on the root file system, just to make sure everything is okay. You can see that kind of fly by when Ubuntu boots up. This does a more advanced check, and it makes sure, and it does all the file systems that are hooked up. And it's kind of useful if you're kind of suspicious that maybe something got messed up. Let's say you had a crash or something like that. But it illustrates what a flag file is, and feel free to do that when it's not going to hurt a thing. And once the system picks it up, it will automatically delete that flag file. So now we can get into actually doing some real stuff. And before we move on, let's create a little area where we can play in. And we're going to create a directory called junk. And we'll jump in there so that as we play around here and create files and whatnot, we have a place to do it. This is one that I have talked about in past videos, and it always catches some people's attention, and they go, I never knew that was possible. This is the cat command. We're going to turn it on its ear, and we're going to use it as a text editor. The cat command is one of the most basic and oldest commands in Linux and Unix, and essentially it does one thing. It grabs text from a file and it either puts it on the screen, or you can redirect that text into another program as input or into a file. In this case, we're going to turn it around. We're going to use cat to redirect the input from the keyboard into a file. So cat will just be the middleman for this. And then here's how you do it. Let's say that you need to create a really fast plain text file. You don't want to open up an editor. Here's how you would do that. So we do cat, and then we use the, I believe that is the less than sign or greater than. I always get those reversed. Anyway, the arrow points where you want the data to go. Just remember that, okay? And we're going to create a file called myfile.txt. And there it is. Isn't it beautiful? Now, when I hit enter, you notice we get a blinking cursor, but there's nothing else going on because it's waiting for our input now. The cat program is running, and it's going to take the input that we give it from the keyboard, and it's going to buffer it and show it on the screen. And I can use enter. And I can just keep typing. I can write a script if I have to, or just write myself a note, whatever. And when I'm done, to put that in a file, we're going to use Control D. Now, Control D is a keyboard input signal that goes to the terminal that says, hey, I got no more data. If you're just sitting at a command prompt and you do Control D, it will actually close the terminal because it says, hey, you're done. It'll log you out and it gets out for you. But in this case, what it's going to tell cat is that I'm done. Go ahead and send that data out of the buffer and put it where it needs to go. So where did it go? Well, it went into a file called myfile.txt. There it is. It created it for us. And if we use the cat command the other way around to actually read the file, then we can see what's in there. And you see what I typed there. It's in there. So that's the first way to use that. The second way to use that is to append some text to a file. So in this case, we just use the same command, but we add another little arrow here. And this tells the system, hey, don't recreate the file, don't wipe everything out, just add text to the bottom. And once again, we get the same effect. So let me go ahead and Control D, and it dumps us out. We'll cat that file and take a look at it, and it added our line at the bottom. Now, isn't that really nifty how that works? This is not a text editor, and there are some quid pro quos. There's some weirdness that goes on here. So first of all, let's go ahead and act like we want to add another line. At this point, if I use control, let's say I change my mind. No, I don't want to add another line. I'm in the wrong file. I messed this up, something or other. I use Control C to get out of the program. Control C cancels a program running in the terminal, tells it to shut down. We should be okay. So our file is not messed up. It's still there. Everything's all right. Now, let's say that I actually typed something. This is line 4. Then I decide, oh, I don't like that. So now I use Control C again. Guess what? It's going to end up in the file. Well, it made a liar out of me. It is unpredictable. Sometimes it works, and sometimes it doesn't. And this was one of them type situations. Let me try that one more time. Let me see if I can get this to recreate this. Let's see. This is line 4. Oh, just go ahead. We'll put 5 in and see what happens. I think if I hit enter, it will do it. Let's see. Now let's go back and take a look at our file. Yep, that's the deal. So if you press enter, it's still going to modify the file. There's actually no way out of it, which makes it kind of strange because if we, let's say we do this again. Let me clear the screen so we're working up at the top. See? No, I can't. Let me get out. So let's clear that screen real quick. Control L does that. All right, so now we're going to do that one more time. And let's say that I type a line here. And then I hit enter. And I say, oh, I don't need that. The only thing I can do is backspace. and I can't move up to that line up there. And if I use my arrow keys, it kind of messes up the terminal a little bit. It doesn't quite know what to do with that. The only thing I've got is backspace. So guess what? If I use Control-C to get out of this, that still put it in my file. What do you want to bet? So the point of this is to be very careful when you're using cat this way. It's okay to create little files, but what I would not do is use cat to append to existing system files, like if you were trying to add a line or a couple of lines to the end of some sort of configuration file somewhere. That might get you in trouble, because if you make a mistake, you're kind of screwed. There it is. But it's still a fun little exercise. Now, a little extra here, I'll show you the best way to add a line to a file like that. We use the echo command. You can do it exactly the same way. I like to put things that I put in the echo command in quotes. And then we're going to append that to my file once again. Alright, so now if I cat my file, you see that added that on the end. But there's a problem with that. Do you know what it is? You cannot do this. You can't run sudo and echo, because it just won't work. But there's a way around that, and I'll show you that later. So we're going to move on from now. Feel free to create all the little text files you want to with cat. Just like I said, it's probably not a good idea to do that on sensitive system type files. So let's move on to our next little guy here. And this is one of my favorites. This is another oldie but goodie, and I've covered this in a couple of other videos as well, but people always love this. It's push D and pop D. Now what this does is it allows you to take directories and put them on the stack. This is a little bit different from the way that the CD command works on its own. We can do some interesting things here. So what are we talking about? Well, usually, let's say that we need to jump into another directory to get something done. We could CD in there, right? And then, let's see, we'll do etc. We'll get into, why don't you do the E too? We'll make it work a lot better. So I'm going to jump into etc, and now I'm in that directory, right? Well, it's not real easy to get back where I was. I can type CD, but that just dumps me back in my home directory. So let's do it this way. Let's use push D. And I'm going to jump into etc. And I'm in my home directory now. So you'll notice now that it says that I'm in etc. and now I have home on the stack. Do you see that? Because the home directory is represented by the little tilde there. That's what the shell uses for a short representation of your home directory. And now I'm going to push D again. And this time around, let's jump into the var directory. Now you see we've got etc on the stack and we've got home on the stack. We've got 3 directories. So now if I do pop D, look, it throws us right back into etc. So if I want to go back into my home directory, it throws us back into home. And you notice that it gives us some output every time we do this. This is extremely useful when you're writing a script and for some reason you need to switch a directory. For instance, let's say that you have a script where you want to create a temporary file and you need to jump to the temporary directory to do some stuff to that file because you're working with a program that will only work in the current working directory, and there are a few out there that do that. So what you would do is you would use push D in the script to jump yourself over there and then pop D back to whatever directory that script was originally run in. So it could be your home directory, or somebody could run it out of a directory called scripts, or the script could be in their local bin directory, or it could be anywhere on the system, right? Well, push D and pop D don't need to know what the present working directory is. It's not referenced to home. So it makes it very useful. feel free to have fun and play around with push D and pop D. It is more useful than you would think it would be. It really is, and it saved my butt in a couple of scripts more than one time. So now we're going to talk about opening a root bash environment. And this is a really cool trick because it's one of the things about Ubuntu is that technically in Ubuntu you are not supposed to use su to switch to root. And the reason why is because the root account doesn't exist. It should work actually, because see how it's asking for a password? It'll ask for my password and then you get in there. But now it's probably going to tell me no, see administrator failure. It does not work in Ubuntu. I thought that it would have some way of doing it, but it doesn't. Why? Because the root account does not exist in Ubuntu. It's locked. So what they tell you to do, if you want to kind of stay as root, you can use sudo s. Now it asks for my password, and I get in here and it says that I'm running as root as big boy. Exit to leave. Okay, well that's no big deal at all. But there's another way to do it, and it's kind of a backdoor method that actually works really well. Just do sudo bash. That's it. Sudo bash. What does this actually do? This opens up a new shell environment as the root user. And there you go. I'm in. And when I want to get back to my regular environment, exit. It's just another way of doing that. It's kind of a backdoor way of doing that, and it's very cool, and it cuts through a lot of crap, especially on Ubuntu where the root account is not working. Also, on a system that does have root, let's say that you do have a root account, but you don't really want to switch over to be the root user. You just want to jump into a root environment. There you go. That'll work for you too on other systems as well. So that's just kind of a cool thing I wanted to show you guys. Okay, make bash execute one command as root. This is really important because remember I showed you that the echo command back there? Let's take this command and modify it and talk about it. I'm going to copy this because echo won't work at a command prompt as sudo. It just won't. It just, for whatever reason, that command does not work that way. So let's clear that screen. And what we're going to do is we'll paste that in, and I will change some of the things about that. Actually, I think it actually just did it, but that's okay. It's already in there. It just put it in there twice. Oops, that was a bad example, Joe. So I'll have to fix that before I get done. After I do the video, I got to go in there and take that line out. Okay, what is this doing? We go back up here. Thank you. Now we'll go back here and let's put this in a harmless file. That's what we'll do, where it doesn't really matter. Now remember, up to this point, you kind of know what's going on with it. We're taking this line of text right here, which is in single quotes, because the command that we're using needs to be in double quotes. So the text for the echo command needs to be in single quotes. And this time around, we're going to put it into our myfile.txt. Is that going to work? No, we're going to have to give it exact. Where are we at here? We're in junk, right? And that's not going to work. That's not going to work, man. You're going to have to do it, give it the whole path. Watch, I'm going to mess this up and it's not going to work. Okay, so now what we have is a command that looks like this. We're doing it as root because it says sudo, and then we're going to invoke bash, and we've used the C option here, right there. Now what that tells bash is that, hey, I just want to run this one command. That means open up a shell, run the command, and then put me back in my own environment. And then, of course, the command is in here, echo, and then I talked about the difference between the single and the double quotes, and I'm told it to put it in this file, and let's see if this actually might work. Well, it didn't give me any trouble there, so let's look and see. And we will go and let's use the less program to look at my file this time around because it clears the screen. Yep, it put it at the end there, so it did that. And it did it as the root user. So this way you can put that particular command in a script And what it will do is it will add something to a configuration file on your system, which is precisely what that's really good at doing. It's a one-line solution. You put it in the script, and it throws it into that file, and it's very slick that way. So that's what that does. And like I said, I will take the extra line out of my environment. I just pulled that out of that's an actual command that I have in an installation script that I have, and I'll just have to change that. It's no big deal at all. And so next we're going to use wget. Wget is a great program. What wget does is it allows you to download files from the internet, and it is very robust. It runs in a terminal you can run in the background. I use this all the time to pull down stuff like ISO images of Linux distributions, because I don't want to do that in a browser. Browsers suck at that anyway. They'll get about halfway through and they'll say the file is done and it really isn't done. No, use wget. And there's also some little arguments that you can give wget that will have it retry. So if your network drops out or something like that, something gets screwy, it times out, then it'll actually try it again later. Wget is very tenacious that way. So right now I have the URL here for wget to go get Google Chrome. So we can just turn that loose and you can see how it works. So what you can do is use your regular web browser, and then instead of clicking on the download button, sometimes what you can do is right click, and then the box comes up and it says copy link, and then you can just use wget at a script. Now, one of the things that wget does is it downloads into the current directory that you're in. So you already have to be in that directory. So for instance, in a script, we use pushd and popd to take us to a temporary directory, maybe create one, pushd into it, popd, and then get rid of it. And you could use wget to grab your installation file. So this is what it looks like. And depending on how slow my internet is, that might be running for a little while. As a matter of fact, it does look like it's going to take it a little while. And it also depends on Google's servers. We don't need the whole file anyway, so I will just Control-C out. You get the idea, right? Right. It's wget, very useful. There's another one too called curl, which is a kind of more of a more secure way to do that. But wget is so dirty and nasty and easy to use and been around forever. That's the one that I always go to. This command right here, this is not one that you'll use every day, but I absolutely positively love this command. So what I want to do is grab this bad boy. I'm going to throw it in a terminal, and I want to put it in here all by itself. So we can push the wrong button. That's not what I want to do. We're not ready for the end card yet. We'll do that when the video is over. Go back to our terminal, clear it, and we'll just paste this in here. I wonder if it'll try and run. No, it didn't run. All right. What this is a very compact and dirty way to find out whether a program is installed on your system and then automatically install that program. It is extremely useful in scripts, especially scripts that depend on other applications to be installed. As a matter of fact, XPT, the program that I've written, has this on the front of it, and a lot of my other ones too. If it relies on a certain piece of software to be there, this will install it. So let me take you through this. So the first command that we have is dpkg, and then we just want it to list. Okay? And we take the list. This is all of the installed packages that's going to give us. So if we just, let's open up another terminal and run that by itself to show you what you get. There you go. That is a list of all the packages that are installed on this computer, right? Well, this uses the grep command to search for a package. I mean, I got 3 of them open now, don't I? So this uses that to search for the package, and if it's on the list, grep will find it, and we're looking for GDebi, and if it finds it, it will have an exit code of 0, which tells the system it worked, right? It found what it was looking for. This little operator right here, the two pipes in a row, what that does is it looks at the exit code of the command in front of it. If the exit code on that command is 0, it doesn't do anything. It stops and it says, oh, that command worked, I don't need to do anything. So if the command in front of it gives an exit code with a higher number than 0, then what happens is that says, oh, well, that didn't work, so I've got to go do this. And in this case, we're going to use sudo apt-get install, which is the old installer for Ubuntu and Debian that doesn't really do much on the screen. We're going to tell it here that, yes, I just put it in the system and do it quietly. That's what the -YYQ stands for, and then we tell it what program to look for. This is one of the most compact little pieces of code that does a whole lot that I have ever seen, and it's very useful in a terminal. And we're going to talk more about stringing commands together a little bit later on in this video, but that is one I had to share because I was writing a script for the terminal and I needed a way to do this, and I found this on some obscure web page somewhere when I was looking for code, and I went, whoever you were a total genius to come up with that, because it is so economic code-wise. So I absolutely had to share that. And we can go ahead and close this terminal because we don't need that one open. And we will clear this one. Hey, I said I was going to clear the screen. Well, it's not letting me. Why aren't you letting me? Meanie. Okay, let's move on to the next one. Oh, this is just for fun. This is also one of those things that works better in a terminal. I mean, rather in a script that's going to run in a terminal. So if you're writing a script, for instance, and you have menus on there and you don't want the cursor to be in the way, then you can use tput. Now, tput does a whole bunch of weird little things. That's almost a language in and of itself, and it just instructs the terminal what to do with the cursor, and it also works with the colors of the text, and tput is amazing. But what I'm going to show you is just these two commands right here. So we got this one, and let me go around over here, and we will pop that in there. Now I have no terminal. My terminal's gone. I can still type. I just don't have any terminal. I don't have any cursor. So in order to get it back, then we will use tput, and it says cnorm there, so let's put that back over here. This one I have to press enter this time around, and now you see I get my cursor back. I just thought that was really cool when I came across it. Tput has a lot of options, and if you're writing scripts, you can get the screen to do a lot of interesting things. So we're going to talk about a terminal that's gone crazy. There are a couple of things I'm going to show you here to do this. First of all, sometimes you might modify something in your environment. If you are actually like editing your bash RC page or editing something in your profile, then you might want the system to reread those to reflect the changes, right? So we'll use a little shortcut to the read command that basically tells the terminal, read this and do whatever you're supposed to do with it, whether it be a list of commands or whatever. And if we just want to reload our environment, we just put in profile, like so. And that's not going to work from the junk directory, so let's do that from here. .pro. I love using tab to autofill because it's also a way to make sure that the command is actually going to work. So there we go. So now it just reread it, and it just reloaded it. It's really not that much to see. Now, the way it's set up in your environment, I have a whole video up about environment that I posted not too long ago, is that in your profile configuration page for your bash login, it will call on your bash RC file. So if you're editing your bash RC file, you've got a choice. You can either do that profile, which will reload everything, or you can put in bash RC like this. And now I've reloaded bash RC. Of course, we haven't changed anything. It doesn't make any difference. Now, what if you want to completely and totally start over. Not only do you want to reload the environment, but all of the little things that you've stuck into memory, maybe you've been messing around and you have created a bunch of variables playing around or whatever. The terminal's going a little insane. It's not working right. Then we use the reset command. If you can get this to run, this is what happens. It logs you out and logs you back in, and it reloads the entire environment, not just your local environment, but the entire bash environment. It flushes the memory. It's just like logging out and logging back in, the reset command. And that's very useful. Very useful indeed. Of course, it did remember what directory we were in, which is kind of cool there. So let us move on. Find a command in history. This is really useful, and I don't think a lot of people know about this. And it's just Control R, and hopefully I'm going to be able to use this because the recording software also uses Control R. We'll see what happens. Well, actually, it paused the recording software. Now, how are we going to get around that? I'm not really sure. I'm just going to have to tell you about this. I can't actually show it working. Okay, I'll just tell you how it works. You can play with it on your own. So what you do is you hit Control R, and then you will see a little extra thing pop up, and it will tell you that you're doing a reverse history search. And let's say that you ran a command like 3 weeks ago, and you kind of remember what it was. You remember a little bit about it. Just type in what you remember, and all of a sudden it'll just start to show up on the screen. And the more specific text you give it, the more it will try and match to that exact command. And that uses history to do that. So we'll take and issue the history command so you can see that. And this will just show you all of your history. So you see what it does is you have a file that's created called bash history, and it's all the commands that you put in there. You can see. Unfortunately, I can't demonstrate that one. You'll have to play with that one on your own, just simply because when the recording software is running, it takes over that shortcut. But I do want to point something out here, and that is that do not get confused, and think that you hit Control S to search, because that's going to do something really weird, and I'll show you what that is. If we use Control S, and you think that's to search history, right? Now your terminal looks all right, but watch this. It's dead as a doornail. I can't do anything with it. I don't understand. What you've just done is you've actually turned off the input from X. So your keyboard input, your window manager is not being able to talk to the terminal for whatever reason. And I don't know why this is here. I mean, it might be useful to kind of suspend your terminal. Like, for instance, I actually use this on my terminal here that's just showing me this stuff, so I can't accidentally hit a key and mess that up. So that's kind of one good reason to do that. But to get out of that, all you do is use Control and Q. And now you notice that all of that input that I put in there, it held onto it and spit it back out. So that's what that does. You're just kind of pausing your terminal. And you need to watch out for that, because if you make a mistake and you think, oh, it's Control S to search, and then all of a sudden the terminal stops working, there you go. Nothing's going to work. You'll have to close it and reopen it and figure it out. So now we're going to talk about stringing commands together. And we're going to string commands together at prompt as they would run in a script. And this kind of goes back to what I touched on before with that compound command that worked with the installer there to grab the GDebi application. So a lot of times you will see that it works like this. Let's just do sudo apt update. I mean, this is one you see all the time in Ubuntu, and well, that's not gonna. None of that's gonna work. Hello? Did you go back and do that again? Make it look right? Okay. Sudo apt update, and then you'll see two ampersands back to back, and then you'll see this one, sudo apt dist upgrade, right? What that is doing is running two commands in a row, and what these two ampersands mean is that if this command exits with an exit code that says everything went all right, which would be a 0, then the double ampersand, the command line interpreter says, okay, run the next command because it's okay. If that command exits with a bad exit code, which would be a number and it would be an error, then what happens is that the command will, or actually the terminal will just stop running commands, and it'll show the error message, and it will abort all the other commands after that. So I also showed you what happens when we do that, where we use the 2 pipes. That's the other way around. The command in front has to exit with a bad exit code that had an error in it. It wasn't able to do it for it to run the next command. Sometimes what you want to do is you just want to run a bunch of commands in order in such a way that it would run like it ran in a script. So what you do is you use just a very simple semicolon, which signals to the terminal this is going to be a new line. So let's just put a bunch of garbage in here and we'll show you how that works. So I want to run the calendar application, and then we'll run date, and then we'll do uptime. You know, I mean, just, well, if you spell it right, it works, man. I know. All right, so we can run those 3 commands back to back, and it'll just run them one right after the other. Now, that's great. You see that I didn't do that right because I typed in the wrong thing. That's good. Because if I would have done that in the middle somewhere, well, let's go ahead and do that on purpose. See, now I get my error in the middle here, but the uptime command did run. So that's what we want it to do. It's just like running in a script. And sometimes that's real useful if you just want to string commands together and you don't want to worry about the exit codes. So those are the 3 ways to do it. And through this video, you've been shown there's 3 ways to do it. And hopefully that takes some of the mystery out of that. I end up a lot of times sitting here and I want to do, like, you know, in a virtual machine or something, I want to do, well, I mean, it's like sudo apt update, right? And then just put that in there, and then do sudo apt, and then dist upgrade, you know, and put that in there. And then I want to, like, reboot the computer and just walk away and let it do that. That's the way you can do it. And it doesn't worry about exit codes. It just moves on through. Okay, so what's next on our list? Okay, I'm not going to demonstrate this one. I'm just going to show it to you. Well, actually, I mean, we could use it. It's no big deal. So let's try this in our junk directory. How's that? This is an extremely powerful command, and this is one that you have to be very careful with. Because if you get anything wrong here, why do you keep doing, you keep clicking that like you want to end and you're not done, dude. What this, well, of course there's no such thing. What this does is it goes through a directory full of files, or directories, and it changes the file permissions. Now, if you want it to go through the present directory, the one that we're in, just use a dot to represent that. Well, doesn't that also represent read? Yeah, it does, but it also represents the current directory. So it would work like this. Yeah, let's change let's see, what have we got in here so far? Let's change these to something that we can see. And we'll do 777. Not there, I won't. There we go. So we're going to give everybody permission to do everything on every file in this directory. Yay! And we got absolutely no output on the screen, which means it did it. So now if we list the storage, and we'll do the long list, which will show us the permissions, you'll see that every file that's in here, 2 of them, they have full permissions. Let's do that again to just once again illustrate how it's working. This time around, we'll give nobody permissions but me. So if I put a 7 on there, remember how your permissions work. That means that you can read, write, and execute. If I want a 6, that means that I'm just going to read and write. And if I just want to be able to read it, that's a 4. But in this case, I will put a 7 on there. That will show that this is changing it. So do it again. Okay. And we'll list it again. And now you see we have those permissions set. This is very useful when you have a whole bunch of files in a directory that are screwed up and you just want to put them on one permission. Sometimes this happens when you pull files off of other systems. Sometimes when files come over the network, the permissions are borked up. You can use this to do that. The only thing that is, you have to be very careful, because if you screw up your permissions, like if you did this on your whole home directory, you would probably screw up some programs. I wouldn't recommend doing that, because some of the files that are configuration files in your home directory are actually, set up with special permissions, and this will make them stop working. This is one you have to be very, very careful with. Only use it on directories full of like regular data files, videos, pictures, text, something like that. Don't use this in a situation where you're working with configuration files. And of course, if you want to change that, all you have to do is do D, and now we are changing that on directories. Pretty cool, huh? Took me forever to find that. Okay, now this gets into more of touching on the programming language side of Bash. I was reading a book the other day about Linux, and the fellow who wrote it was saying, okay, in a script you can do this, in a script you can do that, but then he said, if you ever find yourself having to use this, you might want to consider using a different language. I think that's BS. If you're working in Bash and you're writing a script and you have a reason to use this, that's not a problem. I mean, he was like, well, if you're going to create functions, you ought to write in Python or C or whatever. It's like, why not? It works in Bash. We can keep rolling forward with it, But this is kind of interesting. This is using the concept of ranges. So I'm going to grab this command right here, and I am going to paste it into this terminal, and then we'll kind of go through it, and then we'll execute it, and we'll see what it does. So what I want to do here is I want to grab the DF program, which is short for disk free. I want to make it humanly readable, which is going to give it to me in megabytes and gigabytes and stuff like that. And then instead of just turning it loose and letting it show me everything, I am actually going to give it some specific instructions. See, if I just run df in a terminal like this, in Ubuntu, I get a whole bunch of output on the screen. I really don't care anything about the snaps that are hooked up to the system, the loop file systems, all this other stuff. I just want to look at the actual hard drives in this instance. And the way I'm doing that is using a range to tell it what to look for. So I'm telling it, look for dev, SD, A through Z, and then 1 through 9. And that will show me all the partitions on my drives. Now, chances are you are not going to have a drive that has more than 9 partitions on it. It's theoretically possible with like GPT or logical partitions with the old MBR system, but it's not going to happen. So that works out just fine. And what this is going to do is it may kick out some errors, actually, because DF might exit with an error. And if it does, I told it send that off to dev null, which is it's like a file in the system that if you send information to it, it just disappears. So that's what dev null is there for. So it's like if you have a program that's spitting out output and you just want to make it go poof, that's where you redirect it to go to. So that's what this command right here, it's saying take everything out of the error stream, which is 2, and put it into dev null. So let's go ahead and run that command. And now you see that it shows me more useful information. Unfortunately, it shows me udev in this example, but that's okay. I don't care. Udev is a kind of a mock file system that is used to mount things it's a scratch space for the udev service to work. Udev works when you put in like USB sticks and things like that. But that's okay. I still got my pertinent information because it shows me my actual drives here. We've got dev SDA1, SDA2, and it doesn't show me the swap space either. Because, I mean, who really cares? Like, I do have some swap space set aside on my main drive. So that is one way to do that. And, of course, that comes from a script that I put together that does a bunch of commands. I'll show you that. Now, the second way to do that, and this is really slick, is you can use ranges to make the shell do some pretty groovy stuff here, like create a whole buttload of directories all at once. Let me clear that screen, and we're going to put that in there like that, and I'm going to turn that loose. So what you're doing is you're saying make directory, test, and then I want one that's called 01 through 10. Well, I got no output, so let's see if it worked. There they are. They are all in there. So I have a bunch of little directories in there, 1 through 10, and you can use all kinds of different ranges. There's a ton of them out there to create files and kind of just add this text in to whatever you're doing. Very useful to do. Now, the reason why I came up with that is that I was writing this tiny little program that I wanted to use on my web server called checksys. So let's take a look at that, and I'll kind of show you how that works real quick. So that is in my, wait a minute, hold on, where is that? Let's look at the one in bin, home, bin, chk. There we go, that's where it is. So this is the program. So what this does, it just runs these commands real quick, and that's why I wanted that short command, because I wanted it to give me just the information I need on the server. I don't want to have to wade through a bunch of crap. Very useful tiny little script that I have put together there, actually. And I'll just run it and show you what it looks like when it's running. That's what it looks like. So on the server, I don't even want to open up htop to look at that. I really would rather not bog down the system, especially if there's a lot of traffic going on, a lot of people messing around in Easy Talk or something like that. That way I can sneak in, get a real quick look at what's happening, and then get out. Okay, and the last one that I want to talk about, number 13, is one that you might find useful if you ever have to exit a command that runs for a long time. And I call this the Percy patch because I was writing the XBT program at the beginning of the year. I was doing some actually I'm not writing it, but I was doing some major work on it. And I was running a test one day that was going to take some time to run, and my cat walked across the keyboard. And as soon as the process that was running got done, all this gobbledygook appeared on the screen, and it messed things up. So what I had to do was go figure out how to capture that text and then get rid of it. I didn't want it to affect anything. I wanted all of the text that would go into the system while something was running to go somewhere else. So I'll give you a real-world example of how that works, and we're using the read command to do this, and then we're using discard at the end of that. I call it the Percy patch because my cat's name is Percy. So here we go. So let's just put in a command that's going to run for a while. Let's do sleep. And we'll have sleep run for 5 seconds. Sleep is just a pause command. That's all it is. So while that's running, I'm typing at my keyboard, and you see all of that crap shows up. And then when it comes back to the cursor, it repeats it. It throws it back up there like it's going to do something with it. So we can now clear that. And we're going to do the same command. This time I'll have it run 7 seconds. And we're going to use that new line trick because we want to put this other command at the end here, this read command. So basically what it's going to do is it'll grab up to 10,000 characters and then throw them away. Or at least we hope that's what it's going to do. So let's do that again. What did I do wrong? Oh, I know what I did wrong. No dash. Let's try that one more time. Here we go. So now I'm typing all this gobbledygook on the screen. Watch what happens now. Well, it was supposed to grab that little bit and throw it in there. It works in the program. Wait a minute. Let's try that one more time. Did I do that correctly? I'll bet you the enter got me on that one. Let's see. See what it does. Yep, that time it worked. It works perfectly in a script, by the way. That's just in case you start accidentally punching keys while something runs. It'll grab it and get rid of it and throw it away. So it did that all the way up to the enter. And that is what I have here. Those are some of my favorite commands, and they illustrate how the terminal works and what it does. One more thing that I want to show before I wrap this up, because as I was rolling along here, I got to thinking about that. Let me show you where the exit codes go, because you're probably saying, well, what are these exit codes you're talking about, man? So let's run a program, just as any program will do. Let's run date. And, of course, there's no errors with date. So what we want to do is we want to look at this variable, which is $?? This is a variable is something that the environment uses to hold a little bit of information. You also use them when creating programs because you may create a variable. So look, we have an output of 0. So let's do something stupid. So let's run the RM and a file. And now we've got an actual error message. Hey, that file didn't exist. So now let's look at that variable. Look, we've got a number 1 in there. And that is an exit code that means it's an error. So some programs actually generate specific numbers for exit codes. Like certain kinds of errors will have certain exit codes. And if you look at the documentation for that program, if you can get a hold of that exit code when it runs, you can figure out exactly what the error was if it doesn't give a detailed message. And when you're writing programs or scripts, you can use those exit codes to determine what the next thing is going to do, just like this particular very compact little if statement that I showed you earlier does right here, where we list all of the installed packages. We use grep to see if the one we want is in there. If it is not, grep is going to send a code to the shell that says, I didn't find it, it was an error, it doesn't exist. And then, since we're using the 2 pipes there to tell it to go ahead and run the rest of the next command, which in this case is sudo apt install, and then we force it with 2 Ys. I know some folks see that and go, you don't need to use but 1 Y. Actually, it's documented somewhere. I can't find it. It's what 2 Ys does is it actually makes it so that if it asks you a question twice, it still goes ahead and does it. It's not just like, do you want me to do this? Yeah, I'll do it. If something else comes up, there's an error or something, and there is a yes or no question, it answers yes to keep it going, and then the cube keeps it quiet. So that's basically what that does. So a little bonus script information there. I hope you found this useful. I think this has gone on long enough. I love doing these kind of videos, gang. If you have any more suggestions about them, feel free to send them along. Your feedback is always welcome. And you can join the discussion at Easy Talk. That is a forum that is run by Easy Linux. And it doesn't have anything to do with any big companies. It's independent, it's ours, and it runs on our own server. And it's our own little community. And you're more than welcome to check that out. Also, give Easy Linux a like on Facebook if you're a Facebook user. Also, check out facebook.com Easy Linux. Yeah, I just said that, didn't I? Yeah, no, what you meant to say was check out easylinux.com. That is where all kinds of grooviness happens. It's where it all comes together, and there's also a contact page that you can use to get directly in touch with me. And check out freedompenguin.com for more about Linux. All kinds of groovy stuff there. Thank you for watching the video. Hope you like it. We'll do another again soon.